Today it's my pleasure to talk to you about Conda, Jupyter Notebooks, and Pandas, and how we can use all these technologies, based on Python, of course, to leave Office behind, to get away from this huge Office-matic software that has been a big part of our work life for so long, for several decades now. Well, there is a better way. It is a way of leave that behind, of automating our work to do more with less, because you don't need to pay for licenses. That's the beauty of open source software. This is an introductory talk. We are trying to take people that has no previous experience with Python, no previous experience with Jupyter and Pandas, and help them enter this wonderful world. So let me start. We will start, as we should, at the beginning. What is Python? Python is a programming language that has been here for decades. It was invented by Guido van Rossum in 1991. We are celebrating 30 years of Python. And his idea was to make a simple language, a language that allows us to do some other work. As we have languages that try to be very efficient or try to represent one way of seeing programming, languages for machine learning, languages for object-oriented programming, languages for functional programming, and they are very academically pure. Python, it doesn't do that. Python doesn't try to follow one recipe, follow one way of seeing things and doing things. Basically, it lets you automate stuff. It lets you work. It lets you attack these needs we have and resolve them in the easiest, more friendliest way possible. And that means it's an interpreted language. You don't need to compile the language. You don't need to finish the program and then run another program to change your code into the executable file that you will be able to run. No, you only do a simple text file with whatever text editor you want. You are not tied up to one solution. You can do it perfectly well with any text processor. And then you say, Python, run my program, and that's it. It will read line by line and execute the commands you give. It doesn't have static typing. It doesn't demands from you that you declare your variables and you take care of your variables and you had to define everything you're going to use. No, you can just throw your variables there. It's easy to learn. It's very simple. It is not complex. It's very easy to use. It has things like the for loops that are designed to operate over data structures in a very clear way, preventing many kinds of errors that happened in other languages. It makes a code that is very clear, is very easy to understand. You can read a Python program even without knowing Python and basically get the gist of it, understand what it's trying to do. And maybe the biggest part, the greatest thing of Python is the extensibility. It allows you to create libraries, and these libraries are able to contribute to the language and let it grow. And that has been fundamental for Python because now we have libraries that let us do programming, let us do applications, and great applications, let us do web applications, let us do backend applications, API servers, for example, in a very simple way. Or in our case, let us do data analysis. Let us do Excel file processing. So we can plug in these libraries and let us move forward with them. And that is great. But as everything, it has two sides. Every advantage is a disadvantage. So the problem that the language being interpreted, being read line by line by the language, is that it's not efficient. Even the dynamic typing, the fact you don't have to declare your variables, it prevents a compiler of optimizing your code. Your code is not going to be the best possible code. In fact, as you don't declare the variables, it's possible for you to make mistakes. It's possible for you to assign an invalid value to a variable. So this flexibility that Python gives us, it has a dark side, but it doesn't matter, because what we lose in the optimization of the program, we win in the knowledge load we have, in the ease of programming. And here comes the biggest good news I will give you, especially for things like data analysis. You say, I'm going to process big chunks of data, big files, big sets of multiple values. So this thing that is going to take time, it sounds like a bad idea. Okay, but remember, you can have these libraries that you plug into the language. What they did is that these libraries are very optimized. These libraries are not done in Python. They are done in other languages, and they are compiled, and they are optimized for specific processors, even for specific graphical processors, in such a way you are able to plug them into Python, and the actual processing, the actual number crunching that happens in our programs is done by these libraries. So it's the best of both worlds. You program in an easy to learn, easy to use language, but the actual number processing, the actual data processing is done by very efficient libraries that take all the power from our infrastructure. And we have to tell something else about Python, something somewhat problematic about Python. And it's the tale of two Pythons. In the year 2000, just in time for the new millennium, Python 2 was released. And it was good, it was very good, it was great. And then in 2008, Python 3 was released. And even if it has a lot of improvements to the language, and it's great and you should use it, it was very hard for a lot of applications to migrate. This change from 2 to 3 mean that the code you had in Python 2 doesn't run on Python 3. And sounds weird, but today, 13, 14 years after the release of Python 3, there is still a lot of code in Python 2 around. There is still a lot of application and libraries that doesn't support Python 3. It has been such a traumatic event for Python community, for the Python community, that it's possible that Python 4 is never going to be released. We are going to see Python 3.11, 3 to 12, 3 to 100, but we are not going to break Python and create a version 4 in the foreseeable future. So that's good. It means it's not going to happen again, probably ever. But you have to be careful, because your computer can have several versions of Python, and you have to keep track which version you are using. So you say, hey, David, what should I use? Should I use Python 2 or should I use Python 3? The response is very easy. You should use Python 3 for everything, always. Python 2 is out of service, is out of support since the January 2020. That means it doesn't have security patches. It's not going to be improved. So you should not use Python 2 for anything. You should never use Python 2. But if you have a library, you have an application that requires it, well, you cannot get rid of it. In fact, I use a Mac computer. Mac computers used to need Python 2. They had several libraries of the same operating system that use to need Python 2, and Python 2 was installed by default in Macs, and you cannot take Python out without causing the computer to fail. So Python 2 was there, and it was there for a long time. And a couple of weeks ago, now in March 2023, finally we got rid of Python 2. So let me show you what happens in my computer. If I ask for Python and ask for the version of Python I am using, it says there is no Python in your computer, and that doesn't make sense. I'm David Sol, I love Python. What's happening? And in fact, the operating system of the Mac needs Python. Well, in many computers, in many Linux computers especially, what it happens is that we have two Pythons. Python 2, which I doesn't have anymore since a couple of weeks ago, and Python 3. And I need to type it like that, Python 3. And you say, David, I see your presentation and you say that the current version is 3.10, but you have 3.9 here. Why? Okay. The upgrading of Python is done by the operating system, and the operating system is not at the last version, but you can install the last version. So if I do Python 3.10 version, I can use Python 3.10. And maybe you are starting to see why I see it's a problem, this tale of two Pythons. Because turns out I don't need to put Python, but I need to put Python 3 or Python 3.10, depending on which Python I want to use. And it starts to sound complicated, starts to sound like, David, you said Python was easy, and it starts to sound somewhat complicated. Yes, there is a problem. We shouldn't shy away from the fact that we have to keep track of all these Python versions. But there is an easier way of doing it. And it's by creating environments. We can create these separated Pythons with separated versions, with separated libraries that let us keep things apart. If I have a program that needs Python 2, I can have Python 2 separated in a special place. If I need Python 3.6, I can create an environment with Python 3.6 and do my stuff there. And if I want to use the latest and greatest Python, I can create Python environments with Python 3.10 and keep it separated. And that is great because these libraries we use to enhance Python, they sometimes don't play so well together. So it's better to keep them apart, to keep everything in its place. It's easier to maintain, it's easy to work, it's easier for us to manage. And there are a lot of tools that help us do this. Poetry, BEM, PPM, you tell it, thousands and hundreds. But there is one I like. There is one I would tell you it works fine. And it's the Anaconda distribution. Just going back, I'm going to run Python version in my Jupyter Notebook, which you are seeing right now. It will be bigger. If I run the Python version here, we're talking about how to run stuff in a minute. I see I have Python 3.8 here. That is because the environment I am running right now. This environment, I created it with Python 3.8, and it's in a separate environment, different than the one in my operating system. That's why it's different. It has to do with this kernel I have over here. Okay, and we have this tool. This tool is called Anaconda. Anaconda is a distribution of software for data science. And one of the beautiful things of Anaconda is that it's built for people that it's not going to use Python by itself. It's not for people that just want to do applications. It's for people that want to work with Python for doing data science. It can be used for everything. Don't misunderstand it. You can do application programming with this, but the real market, the real objective of the Anaconda distribution is for you to do data science, machine learning, natural language processing, number crunching. And it saves you for all these problems we were talking about. It tries to make easier the fact of installing all these libraries, keeping all these libraries updated, keep all of these libraries working together in the optimal way. Okay, all of that, Anaconda distribution is going to help us do it. So it's great. It's a very big help for us. When you install the Anaconda distribution, you install a lot of packages. And we install a lot of packages we normally want to use when we do data processing. We have here the installation documentation, what you need to do right now in your computers before we continue is to go to this documentation. Let me open it. Find out the operating system you are using, because it's different for Mac OS, it's different for Windows, it's different for Linux. In all cases, it's very easy to install, but you need to do it right now. Let me show you. Here we have the Anaconda documentation. How to install on Windows. You download the program, an installation program as usual. Run it in your computer. I would recommend for you not to install it as administrator, but install it as a normal user. It requires less privileges and it's easier for you. I would recommend you to install PyCharm for Anaconda if you don't have it. PyCharm is a very nice application, very nice IDE, a program that helps you make use pandas. In fact, I am using it right now. And that's it. If you are on Mac OS, it's the same thing. You download the installer, you execute the installer. As I told you, only for you, I would recommend to do that. Install Anaconda, and that's it. You will be able to do it. If you are an advanced user, you can do it in the console. Or in the case of Linux, you will need to do it on the console. You download the program. You don't do the Anaconda for Python 2.7, install the Anaconda for Python 3.7, and that's it, right? You install it, and that's it. After you have Anaconda installed, you will need to run conda init, so it gets your environment ready in Linux. After you have all of that installed, you should be able to do conda version and see the installed conda version in your terminal. Or if you are on Windows, you can go to the program menu and you will see the Anaconda distribution as a new program group. So please, if you are seeing this at home or you are doing it right now, please take your time to install Anaconda and validate it works. Pause the video and we return in 5 minutes. If you have any problems, please type them in the chat. Welcome back. I hope you have Anaconda distribution installed now. Let me tell you the secret why Anaconda distribution is great. It's great because instead of having Python on top handling Anaconda distribution, what we have is the other way around. We have now the Anaconda distribution installed, and Anaconda is able to control several versions of Python, the versions we need. So we can install a Python 2 version, a Python 3.6 version, a Python 3.8 version, all at the same time. All of them handled by Anaconda. So let me show you how that works. I can create a new environment. So I will say Conda create. The name we're going to give this, in fact, I have it here. The name we're going to give this new environment is Python 3.10. I could use any name I want. It's this N and the name of my environment. And I choose which version of Python I will use. Hey, David, I saw in the presentation that the latest version is 3.10.3. What happens if I put 3.10.3? Anaconda distribution doesn't have it available right now. It's going to be able in a couple of weeks, I hope. Why is that? Because this version, 3.10.3, was released a couple of weeks ago. It's very new. So what we can do is to use the 3.10.3.2 version, or even leave it at 3.10 and let Anaconda find the correct version, right? So right now it's looking for it. It says I didn't found that version in the data I have already here. I'm going to look for it over the internet. And I guess it's going to fail in a minute or so. Okay, no problem. In a short while, in a couple of weeks, we will have that version. If you are seeing this in a recording in a couple of months, probably it will be available or even be a bigger version, right? You in the future, you are able to use Python 3.11 or 3.12 without any issue. If you say, David, it takes a long time to look for it. Yes, because we're talking that Anaconda handles thousands of packages. And when I ask Anaconda to add packages to a virtual environment, it looks the best way of installing all of those packages. So it used to take a couple of minutes. But it's a big advantage when you have a lot of packages to guarantee that they work well together. So I will use only Python 3. I will let Anaconda choose which are the best version to use. It says, no problem, I have Python 3, I will install Python 3. And it's not only installing Python 3, it's installing some basic libraries that all Python environments should have. And it says ready. You have it ready to use. And in a very friendly manner, it says you need to do Conda activate Python 3.10 to start using this environment. And you use Conda deactivate to stop using that environment. What that means, if I do Python version right now, I'm using the Python 3 version, the Python installed in my operating system, the one we saw a couple of minutes ago. But if I do Conda activate, like we were superheroes, right? Python 3.10. One, with the configuration I have in my computer, it tells me I'm working in a different Python environment, so I don't forget. And the second change I will see is that if I do Python version, that normally says it doesn't exist, now it's going to say you are using Python.10.2, the most updated version Anaconda handles right now. That also means that when I update these the versions in this Python environment, it's going to keep updating this Python version to keep me safe with the latest and greatest releases Python has. And if you notice, I don't need to put Python 3 anymore. When I'm working in this virtual environment, Python by itself, it's going to use the Python I use in my environment. You can check it in macOS and in Windows, saying which Python I am using, and it tells you you are using the Python that Anaconda handles in the Python 3.10 environment. That's great. That looks more than great. We can install software in this environment. How do we do that? Normally, when you use Python with a normal package manager, you use pip. You do pip install and the packages you want to install. In this case, as we are using the Anaconda distribution, we use this software called Conda. That is our package manager, Conda. And we ask Conda to install, and we're going to install 3 things: Jupyter, which means Jupyter Notebooks, Jupyter Lab, which is the newest Jupyter Notebook, and Pandas. So we say here, Conda list. Conda list tell me what do I have installed in this environment. It says this environment is Python 3.10. And it has all of these installed. As you see, it's the basic packages. We're going to, if you do this at home and you see, hey, my list is not exactly the same, don't worry, it has to do with the time. The version should change, even the packages it installs by default should change. It doesn't have any problem, right? Now we do Conda install, and I want Jupyter, I want Jupyter Lab, and I want Pandas for now. As it happened before, I installed Python, and it not only installed Python and some packages that were required. It happens the same here. It's not only going to install Jupyter, Jupyter Lab, and Pandas. It's going to install those 3 packages and several other packages, dozens of packages that they require. The big advantage we have with Conda is that it looks for versions of those packages, one that are optimized for your computer, is optimized for your processor, for your operating system, for your version of operating system, and that they know work fine, in fact, work optimally between themselves. That the packages that Jupyter and Jupyter Lab and Pandas are going to install work together. That is great because it gives you a very efficient system, a very efficient environment, and saves you a lot of trouble if there is problems with the versions. So don't worry, and if something happens, and the first time it happens to you, you get worried about it, you can install a new package, or you can update the packages you already have. And it tells you I'm downgrading a package. You were in the version 1.1.1. I'm going to take you back to the 1.1.0 version. You say, hey, I asked you to update to get the newest versions. Why are you taking me back? It's because it knows that if he upgrades this version, it's not compatible and it's going to fail. So they need to take this other package version down. So they work well together. That is great because you don't need to do that. And you don't want to do that. So you can see it here. I asked these 3 packages to be installed, Jupyter, Jupyter Lab, and Pandas. It tells me, okay, I'm going to install this dozen of different packages. Jupyter, Jupyter Lab, and Pandas are inside it, but they are not, by any way, the only ones installed. And it's taking down these packages. You say, hey, even Python, it took it back from 3.10.2 to 3.10.2. It seems like the same version. In fact, if I do here Python version, it looks the same. Yes, it's the same, but it's a different commit of the same version of Python, looking for a version that is optimized with Jupyter, Jupyter Lab, and Pandas. It's what I told you. It's not looking to keep you at the latest. It's taking you to the more efficient, more safe set of versions. It's working in an environment. That's what I love about Condas. And don't misunderstand me. Condas, it's very good for this. But if you are doing development, if you are doing applications, if you are doing APIs, maybe Conda is not the best way of doing it. They try, if you ask them, they say, yes, I can do it. And in fact, you can use Conda for that. But the other solutions have their advantages too, especially for those cases. Okay. So, okay, this is important. If I do Conda list, now it's going to tell me which packages I have installed. And as you can see, I have a lot of packages installed. I'm going to ask how many of them. And it tells me I have 151 packages installed. It was easy, right? You didn't have to install all of them. Okay, now we need to talk something about the Anaconda distribution. The Anaconda distribution, as we saw before, helps me install a lot of packages. Remember, we said, okay, we're going to install all of these. David, I don't see it. In fact, I had to install Jupyter by hand. I had to install Pandas by hand. It's not supposed that the Anaconda distribution had all of that installed by default. Turns out, yes. Turns out the Anaconda distribution installed all of that. And I can check it out here. Conda emp list. Which environments do I have? And in my case, I have 3 environments. I have the base environment, which is the one Anaconda created at the beginning, before this, when I installed Anaconda. We have an AWS environment. It's the one I use at work. It's optimized for working with Poto3, the SDK for Python for AWS. And we have the Python 3.10 environment, the one we have just created. The asterisk means is the one we are using right now. Okay. What do we have in the base environment? So I say, Conda deactivate, get me out of the Python 3.10 environment. Conda activate, and I don't need to say base. If I do Conda activate, it's going to take me to the base environment. How many packages do I have here? In the base environment, I have 426 packages. I have everything we saw in that graph and more, much more installed in the base Anaconda environment. So as everything, there is good news and bad news. There are good things and bad things. When you install Anaconda, the Anaconda distribution, you're installing the Conda packet manager, which is the core, the brain of Anaconda, and you install it a lot, not a lot, a lot of data science packages, right? 3 gigabytes of code, over 1,000 packages you're having there. So Anaconda is big because it has a lot of things that you don't need to install. That's the power of Anaconda. You don't want to install all of that by hand. You want to have it ready. In fact, if I say, do I have Jupyter here in the base environment? Because I am in the base environment right now. It would say no, because Jupyter is written with a while. And it will say, yes, you have all of these installed, Jupyter and Jupyter Labs. Do I have Pandas installed? Yes, I have Pandas installed. I have all of that ready for me when I install Anaconda. Hey, David, but I don't want to install everything. I don't want to have all of those packages. Maybe I'm in a small computer. Maybe I'm in a Raspberry Pi. Maybe I know exactly which packages I want. And I don't want everything. I want just these things. And I see I can create a new environment. We created the Python 3.10 environment and installed only the packages we wanted there. But the big issue is we still have the other environment there. We are duplicating it, right? We didn't delete the base environment. Okay, there is another solution. The other solution is use Miniconda. Miniconda is the Conda package manager and the least possible packages it needs. So if I'm going to a Raspberry Pi, and I know which packages I need, and I want to use Anaconda, do not install the Anaconda distribution there. Install Miniconda, which basically is installed Conda. And with Conda, you can create environments and add the packages you need. Right? So we have these two options. Anaconda, which is all in one. We don't want to do things separately. And Miniconda, which is Conda, only the package manager. And we can do everything with it. If you want to install Miniconda and then add all the packages of Anaconda, you can perfectly well do that. You only lose time because you install Anaconda and save that, right? Okay. We saw how to change environments. I can do Conda deactivate to get out of the current environment. Now, if I do Python version, it's going to say that there is not Python there. Command not found. If I do Conda activate Python 3.10, now I will have my 3.10 version of Python available. If I get out of it and do Conda activate again and enter the base environment, we have it down here. Now Python is the Python version in the base environment, right? Which is 3.8.12. Perfect. We can change. We can have several Pythons installed. The only thing I need to remember is to do Python activate in the environment I want. I can have as many environments I wish. To see which ones I have, I only do from the emp list. And it tells me you have all of these environments. How do I destroy an environment? Because I don't want to keep growing and growing and having tens and thousands of environments, each of which use hard disk space. So it's a bad idea to have too many environments. I would tell you, keep only the ones you really use. You only need to do Conda remove. Conda remove takes out a package. I could say remove the pandas package. But if I do Conda remove all, and I say, well, let me say first Conda deactivate. I don't want to be in any environment, just to be sure. It's a good idea when you want to remove an environment. So I'm going to say Conda remove all the packages for the Python 3.10 environment. This will help me remove everything, and it will remove all the environment. So it says, you can see it over here, we are going to remove all the packages in this environment, in the Python 3.10 environment. It tells me what is removing. And if I do a Conda emp list after it, it should be over in a second. Let's give it a second. And let's be clear, there is a lot of things you can do with Conda. We are not covering nothing at all, everything you can do, but at the end I put some links to the documentation so you can explore it. What I can tell you is Conda is a very fully fledged package manager. It helps you do everything. You just need to look for the correct command. If you see, I now have my two environments, the base one with Anaconda, the complete distribution, and the AWS I use at work. And I like it like that, very simple, just for the things I use. I will go say, hey, David, we're not going to do the tutorial anymore. No, yes, but I'm going to use the Anaconda distribution, the one you should have installed already. This Anaconda distribution has not only Jupyter, not only Pandas, it has installed 1,000 more packages, 1,000 more tools you will learn and use in time. But right now we are going to use Jupyter Notebook. What is the important thing of the Jupyter Notebooks? Remember I told you, we don't need to use a fancy IDE to do Python. We can use a simple, basic text editor. For example, here in Unix, the most simple and horrible text editor I can mention, and don't tell anyone because the guys that use PI love PI. I don't, sorry. I can say I want to create a Python program with PI. Print. Sorry, but I don't like PI. Yes, I know I am a bad programmer because I don't like PI. What can we do? If I see my Python program is there, print. Sorry, I don't like PI, and I can say Python sample PI. Easy, right? I don't need anything to start programming in Python. Yes, but the thing I am using here, the thing you are seeing here, it's called PyCharm. It's one of the best, if not the best, Python EDI that exists. it works very fine. And what does it mean it works very fine? One, it let me have this graphical interface to do my programming. It tells me which files I have. It opens the files for me. It lets me have several files open at the same time. And the other thing it does, it helps me. If I put print, it tells me, okay, you maybe are trying to use print and you maybe are trying to use pretty print. No, I'm trying to use print. And it tells me you need to tell this to print. I love it. It tells me you can put some value you want to print, and you can put a separator, and you can put something at the end. You can save it to a file. You can flush this after you print it. Okay, if I don't remember how to use print, this gives me all this information, all the documentation here right now. And there are other things like if I open the quotes, it creates the closing quotes at the same time, so I can just print. Other thing it lets me do is I don't need to get out of here to run the program. I can run it directly from inside the EDI. I can do testing here. I can open a console here. I can check which packages I have. I can access a terminal. I can do a lot of stuff within my EDI. And this is not the only EDI there is. And you can buy, well, there are free EDIs. In fact, there is a PyCharm version that's community edition that is free. But there are also free EDIs, and these work great. And one of them, one of the free ones, one of the ones you can use right away is Jupyter. Jupyter comes from the words Julia, Python, R, because you can use it for the Julia programming language, for Python programming language, or for the R programming language. Jupyter doesn't use Python programs by itself. It uses IPI files, which means Interactive Python Notebook. So right now, what I'm going to do is to open Jupyter Notebook. How do we do that? We say Jupyter and Notebook. Sorry, Notebook. I forgot to put Jupyter version for you to see the version, but as you can see, we have a Jupyter Notebook here. It works in the browser. It works in your computer browser. And I know for people that has used IDS for a long time, it sounds weird to program in the browser, but yes, you will do it like that. I see my example program here, and I can program here, print. And I love quotes like that. And I love Jupyter. As you can see, it's a text editor. It helps me move around, add text, remove text, everything. I can save it. Hey, David, but I cannot run it here. I don't have the terminal. In fact, if you put the print instruction, it doesn't help me around, doesn't give me that fancy documentation. Yes, you're right. There is not as good as PyCharm, but it works and it's free and you have it already. You don't need to do anything else. So right now you can, okay, let's do it like this. I can continue there. I can save my file here. I can close this window, go to the other window. And I can open a new terminal. No, forget it. I'm going to exit this Jupyter. I can exit two ways. I can, as it says here, Control-C twice to get out, or I can go here and say quit. Server stopped. I have shut down Jupyter. I can close this. And here, as you can see, I got back. I have my terminal back because I shut down everything. Now I can run, sorry, Python example with the changes I made. And I have my, and I love Jupyter. Okay, Jupyter Notebooks is a traditional way of using Jupyter. In fact, everyone says, I want to use Jupyter Notebooks, but they have developed a new interface and it's nicer, which is known as Jupyter Lab. So I'm going to run Jupyter Lab now. And Jupyter Lab is more fully fledged, right? If you see, it looks a lot more like PyCharm. It has all the files here. Let me open my files. It still doesn't give me a lot of help, but it looks great. I can open my notebooks. Where is my notebook? It's here. The same one I have opened in PyCharm. It has my kernel over here. I have all my code and everything opened in Jupyter Lab. If you're following me, you can follow it using PyCharm, the community edition. Well, in fact, no, I think the community edition doesn't let you open Jupyter Notebooks. So you can't use PyCharm community edition. I would tell you, if you're going to do this for real, buying or installing a very professional IDE, it's a worthy investment. But if you are just starting, Jupyter Notebook, the Jupyter Lab, in fact, it's a very good option to start programming in Python with the advantages of an EDI. And it's a free EDI. It's something you can find in all places. You don't need to install a big application. You can use it directly here. And it's the base, right? All the Jupyter Notebooks should be able to run here. And if they don't run here, it means there is something wrong, right? How do I exit Jupyter Labs? You come here and say shut down. Why log out? Because you can have a server, you can have a computer with Jupyter Lab installed and have several users connecting to it with the browser and using it. This computer can be very powerful, have a graphic processor, so many people connect to it and use that infrastructure. In our case, we're doing locally. That's why it says localhost over here. So we only shut it down. After we shut down the server, we can go to the terminal and we see it's finished, right? So remember, you can be using Jupyter Lab to follow up the exercise. Opening this Python web conference Jupyter Notebook with Jupyter Labs. Everything is written here. And please open Jupyter Lab, open the file, the Python web conference notebook, and come here to the Markdown section, because we are going to keep working on it. So we are at the 1 hour mark. Let's take ourselves 5 minutes. stand up a little. If you have any problem, please reach out in the chat. And see you in 5 minutes. Remember, open the Python World Conference notebook and go to the Markdown guide section. So we continue from there in a minute. Welcome back. Thank you for joining us again. I hope you have already your Python notebook opened in the Markdown section. Remember, if you have any questions or you get stuck, you can contact us in the chat. So, how does a Jupyter Notebook looks? We are seeing one now. This is a Jupyter Notebook. The Jupyter Notebook runs in a kernel. It's like the virtual environment it uses, and it depends on the virtual environment where you created it, the Jupyter Notebook version you installed. What I love about Jupyter Notebooks is that it lets us change the way we program. For one side, we can have live code. We have an actual program, an actual sequence of steps written in Python or Julia or R, or there are kernels for other things too. And we can execute that code and see the results of that code. But on the other hand, we can document it. They're not only code comments. We can add text. We can add images. We can add even diagrams or tables to this documentation that help us understand what we are doing. And I have to tell you the truth. A long time ago, I used to do something similar to Jupyter Notebooks. I did these documents where I documented what I was trying to do and how I was doing it, and pasted the screenshots of the code I ran, of the commands I used, and had these documents that added the comments and the code, but they were not good. The code, they were images. It was screenshots. And we always told ourselves it would be great to have something like this, but with live code, something that we can execute. And guess what? That is Jupyter Notebooks. It let us document what we are doing and be very, very clear in this documentation, have a lot of help in this documentation, and also the code, and the code is live. The code can be executed. A Jupyter Notebook is a program. You can run it. You have this button over here, run all, where it takes your notebook and runs it from top to bottom. And that's great. Okay, but how do we document? How do we add these images? How do we add this formatting, these links? It's a different language. It's called Markdown. And the idea behind Markdown is one, is text representation. It's only letters when you write it. And two is very simple. It doesn't try to do everything. It doesn't try to be very, very complex. No, it wants you to write text and for that text to have format. So if I go to this cell, because the Jupyter Notebooks are divided in cells, this specific cell, which is marked with this line in blue, is a Markdown cell. I can double click on it and it changes. It changed from the rendering of the cell, seeing the Markdown pretty, to the actual Markdown code. And you can see what I meant when I told you Markdown wants to be only text. I am perfectly able to read this cell, even when it's not rendered. I can see it has a title, Markdown. It has another title with a link. I see the link here. It has text, and it has a link over here, but it's an image, PNG. PyCharm even tells me which image is it. And it has this admiration at the start. This, if I press Shift Enter, gets rendered. And this is the rendered version of that cell. The title gets bigger and gets bold. The links change, so I can press on it and go to the destination. Let me show you the destination. It opened over here. This is the Markdown guide. It's very friendly. I'll show you later. It doesn't let me show it right now. It can be opened and the images get rendered in the cell. Markdown is simple, and I would tell you that. Remember, when you write Markdown, sometimes we want to be very elegant. We want to do the documentation in a very pretty way, and we try to do very elegant stuff. No, Markdown pretends to be fast. It lets us do formatting. It lets us create beautiful documents, but it doesn't want to do everything, and it doesn't want you to try to do everything. So remember, in Markdown, the name of the game is keep it simple. You want to write your information, you want to format it, but you want to do it simply, very clear, very easy. It should be fast. If you're taking too long to format your text, you are doing it wrong. So how do you do headings? Very easy with these symbols, right? You use these symbols and as many symbols as you want. Only 6, right? But normally you don't pass of heading 4. To write text, you only write text. Something I always wanted to do and didn't know how to do it is how do I break the lines. But let me show you this. If you put text like this, it's one line, right? If I put a line break there, it's not doing what I expected. Okay, if you want a line break, you need to add a couple of spaces at the end of the line. That's the way of making a line break. You can format the text. How do you do it? With underscores. A couple of underscores for bold, one for italics. You can use these symbols for strikeouts. You can do it also with asterisks. It works exactly the same. But I prefer to use underscores because the asterisk gets used for list too. So I prefer to use underscores. But it's the same, right? You can have bold block quotes. It doesn't show a lot, but you have here a line and it's indented, so you can make quotes. It's done with these symbols, the greater than symbols. You can have the titles and formatting inside the block quotes. That is a good question, by the way. How do I do bold and italic at the same time? And that's very easy to do 3, right? Bold and italic. One is bold, 2 is italics. So if you put 3, you have bold and italics. Links. For a link is as simple as doing, what's this? in square brackets, the text you want to show, and in parentheses, the link you're going to have as destination. And if you only want to show the URL, you don't need to write it twice, when to show and when to go. You only put greater than, less than, and it works just the same, right? We have our link here and our link here. We have also lists. For a list, you only use asterisks. That's why I don't like asterisk in the bold formatting, because we use it for unordered list. You can have indented elements that will have different formatting or spaces, right? And you can have numbered list. Something very important, you need to put a number and a dot, and it doesn't matter the number, right? You can put, as I did, only once. You can put 1, 5, 10, 15. It's going to number them in order, always. So don't lose your time trying to number the number list, on only one in everything, and that's it. As you can see, every level of the unordered list has a different symbol. A dot, field dot, empty dot, square, and the numbers got correctly numbered, 1, 2, 3, 4, and the indented ones are 1 and 2. By the way, in PyCharm, if I change the numbers, it changed the numbers in the text document too. So if I do this and I say it is going to be 2, you realize it numbered them for me. It said 1, 2, 3, 4. If I change this to 3, it's going to number it by itself, right? That's one of the advantages of PyCharm. It helps me do that numbering automatically. How do you show images? Very easy. It's the same as a link. The alt text in case the image cannot be rendered, and the link to the image. It can be a URL in the internet. You can put https://domain/ the image, or you can make a relative direction. So I'm saying, look in the image directory, the Python image. And you have to put this admiration sign to say this is an image. So if we see the files we have here, you realize that we have this image directory and I have this Python file. This Python image is the one we are showing here, right? Images Python. Perfect. How do I create an image that is linked? This, for example, it's an image, but it's also a link. Okay, that's very easy. Remember, when we do a link, we put square brackets for the text that we are going to show, and then parentheses with the link. What we're going to do is to take the image, all of these, copy it, and put it inside the square brackets. So yes, we have square brackets, then the admiration to say it's an image, and then another square bracket for the alt text of the image, then the parentheses of the link to the image, and then we close the square brackets of the link, and then the parentheses of the link. First time it takes a little while, but remember what you need to do is inside the square brackets for the text of the link, you put the image. You put all the text that defines the image, and then that way you have an image that is linked. Another thing that the Jupyter Notebooks does, and it's great and looks fantastic, it's Codeblocks. This is code that is not live. It's not, we cannot run this. I cannot run this Python code, but it looks very nice. What you need to do is to put backticks and then the kind of code you are putting. And it's not only code. Here we have a JSON object. Here we have Python code. As you can see, it even you do syntax highlighting. In this case, in this Markdown file, sorry, in this Jupyter Notebook, in this Markdown cell, for some reason, it doesn't render the syntax highlighting. But let me show you something. Let me render this. I will open a file I have over here that is called mermaid example. Ignore the mermaid right now. I want to show you the code block. In a Markdown file, it does the rendering correct, right? It looks great. This rendering, right? We go to the mermaid in a minute. We can also have tables. How do you do tables? With pipes. You put the columns, you put a line to say this is the header, and you have the cells. You can have formatting inside the cells, for example, bold. You use these columns to say this is centered because it has 2 columns, or this is aligned to the right. We could say, no, I don't want it aligned to the right. I want it normally aligned to the left. You see, now it's aligned to the left. But if we put a column here, now it is aligned to the right. How do you put a break in the text? As HTML, right? A break tag. And that's it. And it looks very good. We have our tables rendered. Okay. Let's say this is the basics of Markdown. And we should try to stay within the basics for as long as we can. But believe me, Markdown has extensions, has things it can do besides it. On one side, it lets you do more, and that's good. On the other side, it's not as compatible. You can face the fact that in some platforms, some renders are not able to understand it. But it's good for you to know that it exists. For example, as we do that science with this, as we do things that uses equations, you can use LaTeX. LaTeX is an old format to make equations in scientific articles. For example, this is the formula for the volume of a sphere. As you can see, I could put an image, right? I could make an image and paste the image here. But I can also use these double dollar signs to say, I'm going to use LaTeX here, and I want to have the B, and then I have a sphere as a subscript, and then I want a fraction, and this fraction is 4 divided by 3, and then I have pi and r exponent 3. And my render is perfectly able to get all of that and create this beautiful image. So now we go to the mermaid example. Mermaid is a way of documenting diagrams. So I can say I want a diagram, a graph diagram, which has a start that start state that leads to accept, and the start state also leads to reject. And the renderer do this, it writes my diagram. It says, okay, start, and can go to this. And I can do even more elegant diagrams. It's a sequence diagram which has 3 participants, Alice, Bob, and John. And then Alice talks to John, how are you? And there is a loop that goes from John to John, which is a health check. The name is health check. And then we have notes, and then we have messages between them, right? We can say this message is an origin message or is a response message. And it makes these, which look great. The message, the responses between them, right? The sequence diagram. UML sequence diagram. Hey, David, it looks great. Why not do an image? Why not simply use a diagram tool, export it as an image, and then put it inside or notebooks, or put it inside or Markdown files? Yes, it can work. It has an advantage that every Markdown renderer can render the images. Not all of them can render Mermaid. Not all of them can render latex. But the big advantage of this that you should not discount, it's a decision you have to take, is that this text that we use to create the Mermaid diagrams, this can be in version control. In fact, all of our Markdown files, all of our Jupyter notebooks, all that text that we use to create the documentation and even to create the diagrams is under version control. When we use Git, I can know that someone changed Bob and instead of Bob put David, and it's going to show, and you can see it here in pie chart, it's going to show in Git. Hey, someone changed Bob for David on this day, this developer, and in the commit message even for which reason. That's the big advantage of this. And as you can see, instead of having to open my diagram tool, do the change, export the image again, copy the image here. No, it was very easy to say, no, it's not Bob, it's David. And that's it. I can change my diagrams. If it's not accept and reject, but it's okay and fail, I can change it here in a second, right? And the diagram shows the change. By the way, I'm talking about it, the Markdown files have MD extension. And the most known Markdown files are the ones we use in Git. For example, this is the repository we have for this talk. If you realize, the first file you are going to be shown is the Readme Markdown file, where it says, okay, this is the talk we are giving, this is the hero of the talk, which is the content, and you say, hey, David, this shows like Markdown. Yes, it's Markdown. The Readme of all the repositories in Git, it's a Markdown file, and I can open that Markdown file. You can see the Markdown here. It's one advantage of PyCharm. You can see on this side the Markdown code, and in this side you see the Markdown rendering. But notice, and this is very important, you can read the Markdown file without being rendered. I can read this and make a sense of what's saying. I don't need the text to be rendered. It looks great. I don't see it on render the Markdown files, but it's not needed, right? You can write it and understand it without the need of it being rendered. Okay, so that's it with Markdown, and I would tell you it's very important for you to know Markdown. Let me give you something else. We are talking about stop using Excel for the data analysis. We could also stop using Word. If we change our documents and instead of using Word, instead of using Acrobat, we start using Markdown, we don't need to buy software. We don't need to buy licenses. We can do our documents in a very easy way, in a very readable format, which is not tied up to a specific software provider. And maybe you tell me, okay, but Acrobat, you cannot change an Acrobat document. Okay, let's not go there. You can change an Acrobat document, but let's say you're right and you cannot change an Acrobat document. Here, a Markdown file, you can change it, but if you put it in version control, which you should, then you can change the document and know when it was changed and who changed it. And you can use all the wonders of version control, all the branching, all the merging of changes, all the pull reviews of the changes. All of that you can do in your documents. And I would love more organizations to stop using these proprietary formats for text documents and start using Markdown. I think it has a lot for it. Hey, but you cannot do these very specific and beautiful things we can do with these word processors. Yes, you're right. Markdown is simple. And that's an advantage. That means you're not going to lose a lot of time trying to keep format, to be very exquisite in the format. Now you're going to do your documents to communicate ideas, which is the real reason we do them. But okay, that's my digression about Markdown and how much I love Markdown. But that's not it. Jupyter has Markdown. Let us have Markdown cells. This one. But we can also have code cells. This code cell, if I go here, if you see this is code, it's Python code, and I can run it. And as you can see, PyCharm that tells me you are running an import statement, and I'm going to import a library that is called this. And what does import this do? I press Shift, and while Shift is pressed, I press Return. That runs a cell. In the case of a Markdown cells, it renders the cell. Let me see the cell. Render it. In the case of a code cell, it runs the code. And in this case, when I run this cell, I get the Zen of Python, PAP 20. Whenever you are programming Python, whenever you are using Python, remember this. This Zen of Python is great. This Zen of Python can help you a lot when you're using Python. As verbose, as poetic as this seems, which is a poem to my eyes, it's very important. It guides you when you are using Python. It tells you what you should be striving for. Right? So read it. I would even tell you print it and paste it in front of you in the wall, so you never forget all of this. It's great. Put the link here even of the PAP. Okay, this is what you say, okay, so you import this library, and this library, what it does to show you the sense of Python. Yes, Python sometimes is a very playful language. I told you, sometimes doesn't take itself very seriously. Another example is to say important gravity. And what it does is to show you a comic in the web. A very good comic from XKCD, which it did about Python and saying Python is wonderful. Randall Munroe, the guy that writes this comic, which is great. Just put Python is great. It's very simple. You cannot do everything. And how are you flying? Well, I just put important gravity and I'm flying. That is how Python feels. You want to do API development, you import a fast API and that's it. You want to develop an application, you import a library and that's it. You want to do data science, you import the library and that's it, right? That's why Python it's so popular. Okay, as everything, there is good news and bad news. The good news is you can have these markdown cells with documentation. And you have these code cells with actual code you can run. You can say, run it, right? I can run it here, or I can do Shift Enter and run it here. And I can say, okay, name, the variable name is going to be Kane. Tell me which name I have, Kane, and then I say, okay, no, forget it. The name is going to be Able, and then it shows Able. It makes sense, right? Name is Kane. I print the name is Kane. I say the name is Able. I print the name, and it says Able. But as we're doing this interactively, as we can run each cell in isolation, which I can tell you it's great when you start using this, start seeing the power of this, it's great to be able to run pieces of code interactively. It's not like you need to run everything. No, you can run only the pieces you are interested in. You can check those pieces. You can build your program incrementally. You first run a piece, you see that that piece works, then you run the next piece, then you run the next piece. You realize there is a problem up here. You only need to run the piece that failed. Not, you don't need to run everything. It's great when you start doing that. It helps you do your programs. It helps you be productive, but it has an issue. If you start running your code in disorder, you cannot guarantee that if you run your code in order, you say, okay, run everything, it's going to do the same. And let me show you an example. What happens if I run the able assignment and then I print the cell on top of it? It shows able because I have just run able. And then I run the cell that says Kane, and then I print the name below able. Now it doesn't make sense. I see that there was an assignment that it says Kane, but it prints able. And then it gets assigned able, and when I print it, it says Kane. What the hell? If I see this in a notebook, I would tell you I don't understand how Python works. Okay, you can check these numbers. If you were asking what is these numbers, it tells you the order the cells were executed. 8, 9, 10, 11. This one is the first I run. That's why the 9 prints able. Then I run the assignment of Kane, and then I run this one. But you need to check these numbers. And if these numbers, these cells are not together, they are in different parts of the document. And if I ran 100 cells between these, it can be very hard to realize what happened, why the cells have the values and give the results they gave. So the moral of the story is be careful. Yes, it's very nice to be able to run these cells of code in isolation. It's very nice, very productive to be able to rerun only the parts you need to rerun, but it can get messy. So always when you finish, when you say, okay, it works, I think it's ready, I think I've done whatever I want to do, run the notebook again from the start in a clean kernel. So you say, and that's why these buttons are here, restart kernel, which means forget all the variables, forget everything you knew. Let's start from scratch and run everything from the first cell to the last cell. And I want to see that my notebook, if run from the beginning in a clean kernel, in a clean environment, it will run okay, it will give the results again. It's something you should always do when you are ready, when you say, I have finished, right? It's the only way to guarantee that your notebook performs as you expect. If not, you run the risk that as you were running things in disorder, things doesn't work as you expected when running off. That's the only thing you need to be careful when using Jupyter Notebooks. Perfect. We are now to the interesting part, pandas. Let's say all of this, Python, Anaconda Distribution, Jupyter Notebooks, all of that is a scaffolding. It's a very nice scaffolding. It's a very nice environment and very nice tooling to get to this. The Python data analysis library, Pandas. Pandas, it's an open source, free, completely free library. You don't need to pay anyone for it. There is no community edition and professional edition. No. This is free for everyone that lets you do data analysis. For one part, it's based on NumPy. NumPy is a library for numeric processing, number crunching. And it's a very efficient number crunching library. It doesn't do the calculations in Python, which is interpreted and you could say is slow. It has this code, these libraries that were developed in other languages that are compiled and they are very, very efficient. So as we said before, it joins the best of both worlds. On one side, we can develop in a very easy way, and you're going to see it in a minute. And on the other side, we can have very good response. Use the infrastructure we have, the processors, the memory we have, even the graphical processors we have at full power. And that's great. That's why Python and Pandas is so popular. And as Pandas is standing on top of NumPy, a lot of other libraries are standing up on Pandas. A lot of other machine learning and graph libraries, visualization libraries, use Pandas to handle the data. It's a wonderful synergy. It's wonderful which what these libraries has managed to do. The people that build them have managed to give us to work. We're going to import NumPy and Pandas. Hey, David, we're more interested in Pandas, not so much in NumPy. Yes, don't worry. We need NumPy for some stuff. But here is something something weird, something something the community has accepted. No one does import pandas and that's it. So you need to say pandas show versions. Now everybody, and I swear to you, everybody do import pandas and use an alias and use it as PD. And all the documentation you're going to find, all the examples you're going to find, all the courses you're going to find, they are not using pandas and writing pandas. They write PD and that's it. And the same for NumPy. They don't write NumPy, they write NP. That's why we import NumPy as NP. So in the future, when we want to use something from NumPy, instead of using NumPy dot something, we use NP dot something, which you will find in all the documentation, all the tutorials, all the examples, all the code you find, right? You see this underscore here, it means I have not run this cell, right? If I try to run PD show versions, it's going to fail because PD is not defined. I need to run this import first, which is running. That's why it looks like. Moving here, when it shows the number is that it has finished running. And then I can run this one, right? Happens here. Ah, there it is. It shows me a warning. It says set of tools is replacing these utils. Just don't worry about it. And it tells me for pandas, in the point of view pandas, which versions I am using. And this is, I would tell you, somewhat important. It's not something you should take care of every time now, but it's good to know because it defines the small difference you can see when you run it in one computer and another computer. So you have the specific pandas commit you are using, the Python version you are using, the operating system bits. Some time ago, the operating systems were 32 bytes. Normally, now everything is 64 bytes. The operating system, as I am in a Mac OS, the operating system name is called Darwin, the version of the operating system, Darwin in this case, the full text of the kernel I use, the kind of computer I use, it's an Intel 64 bits, the kind of processor, Intel, byte order, little endian or big endian, it has to do with where the sign is stored in the new numbers, the language of my computer, and the version of the packages. It starts with pandas itself. It says which version it has. The version of NumPy, which is very important too. Time zones, state tier, pips, a lot of packages pandas uses a lot. It's not the only ones it uses, are the most frequently used, including some that we don't have installed. Is the library to connect to MySQL databases or the library to connect to Postgres databases. It's okay. If we install them, they will show here. If we don't install them, nothing happens. Everything is okay. This OpenPIXL, we're going to talk about it later, but don't worry about it right now. We have all of these, right? A lot of versions. Okay, pandas work with something, with a data structure it calls a data frame. For example, I want to create a data frame. Pandas create a date range. I want dates starting from today, 7 days. And I want it to show what it has there. And it says I created an index, and this is important, it's like the columns, in this case the rows it's going to have in the data frame, and the different days I asked for. 7 days, right? 1, 2, 3, 4, 5, 6, 7. 7 periods. It tells me what kind of data it is. It says it's daytime data and which frequency it has, days. I'm going to use this range as an index. It's going to define the different records I will store. I will have different columns in my data. And let's think like a spreadsheet, right? The index are the rows and the columns on this side to make our table. And in each of the cells we're going to create, we're going to put a random number. You see, I'm using NumPy here. NumPy, please give me a random number. And I want 7 numbers and 4 numbers in a table, 7 days and 4 columns, A, B, C, D. And all of that I want in a data frame. Let me show you something. If I only do the in NumPy random part, what I get is this table, right? I got 7 rows, 0 to 6, and 4 columns. And in each one of them, I have a random number from -1 to plus, no, sorry, from minus, I'm not sure from minus what to plus what. I think it's a normal distribution with 1 standard deviation. Doesn't care. These are random numbers. So it's going to take these random numbers and put it into a data frame which has as index, instead of having 0, 1, 2, 3, 6, it's going to have the dates. And in the columns, instead of having 0, 1, 2, 3, it's going to have A, B, C, D. So let's run that. And there it is. We have our random numbers, which should be different because they are random. And we have dates here as index, and we have the letters A, B, C, D as the columns. It shows me my data frame, and it tells me the dimension of my data frame. We could also create data frames using a dictionary. I'm using a dictionary over here, a literal dictionary, which has the columns, column A, column B, column C, column D, and then the values in each column. Here you put only one value. Here you put only one value, which is a date. Here you put only one value, but you are saying that it has an index with 4 numbers. Here you are creating an array with 4 numbers. Here you are saying you want a categorical column. That means it's not a string, but it's a category. You have a list of values that says test train, test train. So I see 4. It's going to create one field only, one column, or it's going to create 4 columns. And be with me, we can run each of these in isolation, right? We can copy this and paste it here. I want 1 4 times with this data type float32. That's why it says float32. And see how nice I can add float cells. And here I have int32 as a data type, right? It's not a float value, it's an integer value. This helps to optimize the code, right? Remember, NumPy and the pandas run optimized code. And I say I want 3 4 times. That way it shows 4 times. I could say, no, run, I want to have 5. Perfect. I want 8 values. I don't want 4 values. Okay, we have it 0 to 7, 8 rows. So now we have 3 4 times. All of this is the things we are feeding our dictionary with. And that we are sending into a data frame. And which is the result? 4 values in 6 columns. And what it's doing is to repeat the values that only show once. This foo, a string that only shows once, is repeated. This one is repeated. This date is repeated, right? Hey, but I remember this was a string and this was a categorical value and that this was an integer. That's why it doesn't have a dot zero. This one was a float, but float 32. How do I know which types each column has? Okay, you put the data frame variable, the df2, and you ask for the data types. And it's going to tell you, okay, column A is float 64, column B is a date time, C is a float of 32 bytes, so it occupies half the space of this one. This one is an integer value, and this one is a category. And at the end, we have object. Object means string for pandas. Mind this, in a normal list of Python, we can have different types in the same list. In pandas, every column should have the same kind of data. I can't have a B column that sometimes is a string and sometimes a number. Either all of them are strings or all of them are numbers, right? Each column has a specific data type. Why? Because we are using optimized code and it needs to know the data type of the data. We can also see the shape of our data frame. It's to say how many rows and how many columns does it has. 4 and 6 in this case. If I choose the other data frame, the one we created first with 7 days and 4 columns, it gives us a different shape, right? We can describe our data. This is very nice. Okay. I know that it has 6 columns, A, B, C, D, E, F. But here I know I only see 3 columns, A, C, and D. Why? A, float 64, C, float 32, D, float int 32. The numeric columns. When I do the describe, I am only seeing the numeric columns. And it's telling me how many values do I have, because even if all of them are numbers, there can be null values. So it's telling me no, all the values are there. Every row has a number. What the average is, well, that was easy to calculate, right? 1, 1, 3. Okay, the average is 1, 1, and 3. What is the standard deviation? Say 0. It's a constant value, and that's what the standard deviation 0 means. Which is the minimum value? Which is the maximum value? 1, 1, 3. It means all of them are 1, all of them are 1, all of them are 3. And the percentiles this means which is the value that covers 25% of the smaller values, the 50% is the median, and the 75%. This, as simple as this, data frame describes, help us to take a good idea of how our data is distributed. In a simple instruction, I know I don't have missing numerical values. I know that they are constant values, that they are only one value, and I know which value that is. I know it's this value. Like that. If I do the same with the other data frame, it's going to tell me, okay, you are not missing values. The average change. The standard deviation change, but it's around 1, which I would expect, which is the minimum value I have, which is the maximum value I have in each column, right? And more or less where the values are. I would expect this to be 0, more or less like that. It's random data. But it gives me an idea of what kind of data I'm dealing with in a very easy way. I don't need to scroll in a spreadsheet to get all this information. Okay, David, that's great. Sounds very good, but I only see the numerical data. I don't find the other data. Can I have information about it? Yes, you can. You put describe and you say include everything, not only the numerical columns. It sends me another warning and it says describe data types, that datetime data. Right now is categorical instead of numeric. That's why it's not covered in the numerical columns. And it's going to be removed. If you want to take out this warning, please put this. That time is numeric. Okay, great. Let's see about that in a minute. Now I have all the columns. It tells me how many columns has values. 4, 4, 4, 4. That means I don't have invalid values. How many of those values are unique? Okay, forget about this. In this case, and this is the important thing, it's mixing up two kinds of data. Numerical data, which we saw before, and it includes the mean, standard deviation, minimum, and maximum. And if you realize the numeric columns, it has values. For the non-numeric columns, it doesn't have values. It's not a number. It doesn't know what to do with it. Doesn't know how to get the mean of test and train, right? What's the mean of that? And on the other hand, it has this unique top frequency, first and last, that doesn't make sense in the numerical data. So it puts not a number. I don't know what to do with it in the numerical columns, but I do know what to do with it with the other columns. So the moral of the story is use describe for the numerical columns and analyze the numerical columns by themselves. And then I can remove the warning using that time is numeric true. And notice this, in this case, if I put that time is numeric true, the date appears in the numerical columns, right? It tells me what the mean is. Now it says what's the mean of the date. It doesn't do that before, right? Because these dates were categories, they were not numerical values. If I say that time is numeric, now it's a numerical value. It has advantages. If I have different dates, I can know which is the middle of the dates, the average of them. I can know which is the minimum date, maximum date. That's why this is going to be the future, right? But I can say, describe the columns that are not numbers, right? So it will complement. Here I have the columns in describe. I only have the columns that are numeric. And if I do this, I got the columns that are not numeric, the other ones. So as you say, I can see just the B, E, and F columns and only have the information that makes sense to non-numerical columns. So that's the best way of doing it. Instead of one describe, you have two describes for the numerical columns, for the non-numerical columns. What can I know of my data? Because this is data exploration. What can I know with this just by looking at this? Okay, I can know that I don't have empty values because we have 4 records in all cases. That's great. I'm not missing data. I know that we have 1 unique value in the B, 1 unique value in the F, and 2 unique values in the E. That means that everything is the same in the B column, everything is the same in the F column, which is all the F columns have foo, all the B columns have this date, and that I have 2 values in the A column. That's great. It means I have 2 values. And I know that one of those values is test. I know that the frequency is 2. That means I have 2 of these, 2 of test, all right? If I had 3 train, here it showed train and it says 3 are trained. Right now, it took the first one, alphabetically speaking, right? And that's it. That's great because it helps me analyze my data in a very quick way. I have this set of data, I run describe, and now I have an idea of what I am dealing with. How many columns, what kind of columns, what kind of data, how many data I'm lacking, how it's distributed in a glance, very quick. Okay, how do I select the data? For example, I can take only 2 columns, and it looks a little bit weird that I have double square brackets. We will talk about that later, but for me, believe me, if you want to select several columns, you do this, double square brackets. And what it does, it's to select only the columns you want. It's returning me, and I want to be very clear of this, it's not changing the original data frame. The DF2 data frame, that stays the same. If I remove the selection, I see the data frame is there. It didn't change. When I add this selection, I'm creating a new data frame. This is a different data frame that only has the 2 columns I selected. Hey, and what happened to this data frame after the cell run? It's destroyed. As I didn't assign it to anything, as I didn't say selection, it's equal to this data frame got created, got printed, and then it got destroyed. The kernel, the environment I am running, forgot all about it. Maybe you think, what a weird way of doing things. But this is the base of something that we call chaining, that the idea is you have your original data set, and you're not going to change it. Because if you start change your original data set, you cannot reproduce the results. As you have modified, if you run everything again from the beginning, you cannot guarantee that it's going to do the same. And we want to avoid that. We want to keep our original data set the same. So if I want to run everything again, it gives the same result. So we don't create copies of the data set with the changes. What we do is to apply the changes in the moment and change all the processes we are going to do. And we are going to see it in a minute. The result of this command is a data set, a smaller data set. And one way to check that is I can take that and run a method over it. So this describe that we used to run on the original data set, and I can show it here. It is running on the original data set that has the A, C, and D columns. I can say, okay, create a new data set that only has the E and F columns and describe that new data set that I created. That new data set that is going to be destroyed, right? It's going to be destroyed just as soon as this run. And as you can see, it shows the describe of the new data set, the one that only has the E and F columns. This one, the DF2 dataset, that is not changed. This dataset that got described here, that doesn't exist anymore. But in this moment, when I run this, it existed and it got described. And it was a nice way of getting the description only of the columns I was interested in. Okay. We can select with a binary mask. We have 4 rows, right? 0, 1, 2, 3. I can say I don't want the first row, I don't want the second row, I want the third row, and I want the fourth row. Right? This is a binary mask. And I'm going to say I want to see of DF2 this mask. The 0 row was not selected because it was false. The 1 row is not selected because it was false. The 2 row is selected because it was true, and the 3 row is selected because it was true. What I wanted to show you with this, remember the double square brackets we saw? What's happening is that we're taking this and putting this inside of the brackets. That's why we have double square brackets, because our mask is getting inside the square brackets of the data frame. You notice it runs the same. If I run it with a mask, do the same thing. Let me even add it here. That's why we have double square brackets, because we are having a binary mask inside. In the case we had before, instead of a binary mask, we had a list of columns, but it's the same thing. That's why we have the double square brackets. Okay, I want to see the data. Imagine I don't have 7 rows or 4 rows. I have 1,000,000 rows. How can I see a sample of the data? Okay, we have the head and tail method, and this shows the first and the last. If you don't put a number as a parameter, it shows you 5. These are the first 5 rows. We have 7, right? From the 23rd to the 29th, showing me just 5. In tail, I say I only want to see the last 3, 29, 28, and 27. 27, 28, 29, right? The last 3 rows. Okay, I want to see the index. I only want to know what index do we have. Perfect, it's a date time index. Remember, we create this index by hand. We have the 7 dates, right? I want to see the columns. Perfect. A, B, C, D, and they are kind object, which in pandas means string. I want to see the complete data frame. Here we have the complete data frame, right? 7 rows, 4 columns. I have to scroll to see all of them. Normally, the Jupyter interface is not going to show you 1,000,000 rows. I think it shows you like 50 and says there are more, but I only show 50. And it only shows you like 20 columns and says, okay, there are more columns. I don't want to show too much because you can have problems with your computer. We can sort the information because right now it's by date, but the numbers are in disorder. I can say sort the index. The axis is 0, is this axis, the dates, but do it in descending fashion. Ascending false, it's to say descending. What's the result of that? From the last date to the first date. right? So this 2.8 minus 287, it's now on the top. The data from 29. I can sort the columns in descending order. Now the D is going to be at the start. DCBA, right? Hey, David, how can I do both of them? I want to invert the order of the dates and invert the order of the columns. Check this out. When I do this, I am not changing the original data frame. Even if here I sorted them in descending order, here they are in ascending order because the data frame, the original data frame didn't change. The original data frame was not modified. So that means this is a new data frame that has the dates in descending order. That means I can use this data frame that has the dates in descending order and change the change of order of the columns. So I'm going to take the original data frame, invert the dates, and then that one, the one that I inverted the dates on, that is a new data frame, I'm going to invert the columns. And voila, here we have it. The dates are inverted and the columns are inverted. This data frame is a new data frame, right? The original data frame was not changed. And this, let's change something and let's change something else, is what we call chaining. I have to tell you, yesterday I learned that to make this more clear, I can surround everything in a parenthesis, and I can put here the line, and I can put here the line to make it more clear. I'm going to take that data frame, I'm going to sort the index files, and I'm going to sort these index files. So it's clearer, and remember, clear is good. And it runs just the same. You need to put these parentheses so it doesn't complain that you put some spaces here. It makes the command, the cell, ignore its spaces. So it's clearer for us, right? So it's a very good tip I learned yesterday. Okay, great. I can order by the indexes. I can order by the column names. What about if I want to order by the data? Yes, you can. You say, instead of sort index, you say sort values. I want to order the data by the A column. And as you can see, it goes from the least value, the minus 2.8, to the biggest value. Right? From less to more. Hey, David, I don't want to do that. I want to sort in the other sense. Sending false. Here is ascending, right? It started with the least value and go up, up, up. Now I want it descending. I want the biggest value of A at the beginning and go down, 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 down to the least value. No, but I want it over the C column. Change here. And now you have it over the C column. The biggest value to the lowest value on the C column. And it changed everything. The dates, you realize, are in disorder because now the C column has the order. Remember, I'm not changing the original data. I'm creating a new data frame with these values that gets destroyed as soon as we get out of the cell. Okay, I want to sort the values not for columns, but for rows. I want to reorder the columns using the values. Sort values in the axis 1, columns, over the data in this day, right? What is the result? The 23rd is the day that will go ascending from the least value to the biggest value. So the columns are in this order. Now it's A, B, C, D, because the order is set by the columns. That's how we can order with the values of the data, the rows or the columns, right? And it's very easy. You can do it very fast, and we can do this sorting automatically. We don't need to do it by hand. Okay, we can choose just one column. This is strange. If you only want one column, you can specify that column and that's it. If you want several columns, and we talked about it before, you need double quotes, double square brackets, sorry. And you can select the columns you want. You can select only some rows. I'm going to select from the second row. This is 0, 1, 2. From the 25 to the 5th row. This is 2, 3, 4, 5. But the 5 is not going to get selected. So we should get only to the 27, right? Like in Python, this last value is excluding. So we have 2, 3, and 4 rows. But we can select by the value of the indexes. I want to select from the 24 to the 28. Yes, of course, you can do that. From the 24 to the 28. Be careful, in this case, it was not excluding the last value. The last value was included. Yes, it's different. We can use this function, lock. This function let us select by row, by the value of the row, and by the name of the columns. Both things at the same time. So we are selecting from the 24 to the 28, and at the same time only the B and C columns. So we can cut just the data we want. We can select one value only. And this is very interesting. If I select several values, I get a data frame. This is a data frame. How can I know that? If I say type of this, it tells me this is a data frame. Let me add it as a different cell. So the result of my function, remember, is a new data frame that only has the data I got selected and gets destroyed right away. If I check what kind of object it is a data frame. But if I select only one value, if I say I only want this row, this column, that is only a value, I got a scalar value. This is not a data frame. When you select only one value, you get just one value, not a data frame. Right? It's a NumPy float 64. It's not a data frame. It's something to take into account. You can select individual values and not having data frames. There is other way of selecting only one value, that is the at function. And at, it's going always to return you just one value. You could also use the iLock function. Lock lets you specify the indexes. iLock does it by number, like it was a list. So I'm here saying I want from the second to the 4th row and from the first to the second column, right? And I'm doing it by number, not by index, not by the value of the index. And it works like it works with this. I can say all of them, but only some columns. I can say some rows, but and all columns. I can use the last value. And as is a comma, I'm saying, give me the first line and the last line. You say, how can I do a head and a tail at the same time? Well, like this, I lock, give me the first column and the first row and the last row. Or I can get the first value. The one is at the very beginning. Or I can say, let me add it. I want the last value. -1, comma, -1. Right? This is the last value, last day, last column. And we can use I add to get these unique values also, right? Okay, great. I can select only some columns, only some rows. I can select both, only one, some columns, some rows, specific values. That's great. I love it. What if I want to analyze the summary of the data, not each cell individually, but all of them? I can do a count. The count is telling me for each column, how many values do I have? And I can do this count by row. Each row, it has 4 values. Okay, great, sounds nice, but doesn't seem very interested. Yes, because count is only one of many functions we can use. We can perfectly well say, give me the sum of the values. Right? And for each day, it's going to tell me the sum. And we have a lot of summary functions. Excellent. And we can say, select the values depending on the value itself. For example, I'm going to say, yeah, let's go so here. I have the data frame, and it has negative values and positive values. I can say, choose only the values which are bigger than 0. Nice, isn't it? The values that are not bigger than 0, the negative values, get substituted by not a value. Again, we are not changing the original data. We are creating a new data frame that only has the cells where the value is bigger than 0. The cells that didn't match that condition don't exist. That way, it shows not a number. Okay, give me the count of those values. 2 values in the A column, this and this. 3 values in the B column, 1, 2, 3. 3, I'm sorry, 4 and 4, right? And we can do the same in each day. Each day, how many values does it has? Okay, I want a more complex condition. I want values that are bigger than -0.5, but less than +5, right? Values that are in the center. I want to get rid of the outliers, the values that are too big or too small. I don't want that. Nice, I have only the values that are between 0.5 and -0.5. Or the other way around. This is and. I want the values that are less than 0.5 or bigger than 0.5. I want the outliers, right? This data frame and this data frame are complementary. The ones that have a value here, they doesn't have a value here. But the data frame has not changed. Sorry, it's the other data frame. I want to show you something different here. I can say, I want to check the values in the E column that say train. It gives me this series, this data frame of Boolean values. And it tells me, no, this was not trained, this was trained, this was not trained, this was trained. False, true, false, true. Perfect. This is the binary mask we use, right? This false, true. We are going to put that binary mask into the selection for the dataset. And that will take me only the records, only the rows that say trained, right? Now, that's how this works. This part over here between the square brackets generates the binary mask I'm going to use for the selection. This one is not. This symbol is, I want the ones that are not trained. We have only the test. If we had several values, it would have taken all the values except trained. We have other condition that is in. I want to select several values. I want to select several states, several countries, several categories. Perfect. You put in this column is in one of these values, yes or no. In this case, it's only taking the test ones because we don't have demo ones, but it should have worked. We have our data frame selecting only the outliers, only the values that are too big or too small. And I can say, select me only the values that are NA, that they are not a number. What it's going to do? It's going to tell me only the values true. Realize this A on the 26, it's true. B on the 26, sorry, it's true because they are not a number. It's a binary mask, but in 2 dimensions. So I can put all of these inside the condition, and it's going to bring me the values that doesn't match the condition. What I'm trying to tell you is you can do very particular selection choices. I can say, select me only the columns that are numbers. Like in the describe, right? But I want to work with this data. The way to select only numbers is like this. Okay, I have this test and train values in the column E. I can run a function to decide if a value should be accepted or not. This function is a lambda function. It's a function I'm declaring right here, right now. It will receive a value. I say it's the delta function. And it's going to check the E field as a string, the second letter, and it expects to be S. Sorry, this is the third letter, right? Because it's 0, 1, 2. So it's going to get test because 0, 1, 2, the third letter is an S, but it's not going to get trained. Right? So it's a function that decides which record should it take or not. And if you see, we can do a lot of stuff here. We can make a function as complex as we want. We talk about how can we select these values, and we can chain this with an aggregation operator. So only the values that match the condition are going to get sum. So this is the sum, but only of the records that match the condition. And we can make the same sum, but over rows, not over columns. We can get the max value for each column. We can get the max value for each date. Let me have the code here. I can get the average of each column. Hey, David, but I want the average of all the columns, all the values, all the rows, all the columns. If I do mean only gives me the columns, and if I do mean axis equal 1, I only get the average of each date. How can I get the average of everything? Okay, remember, what we got here is a data frame. So I can change the functions. I get the mean of all the columns, and I get the mean of all the columns at the same time. I use the mean of this data frame. This is the average of all the values. Okay. I can group values. I have in this column test and train. I want the sum of these values for the test and for the train records. So I'm going to say group by the column E, and once I got the group by, I want to get the sum. And I get the sum of all the numerical columns for the train and the test values. So I'm grouping. Doesn't make a lot of sense because the values are fixed, but it gives you the idea. You can get summaries for groups. You can transpose the information, right? The other code cell here. We have our data frame. If I transpose the data frame, what I get is instead of the rows will be on the columns, and instead of the columns will be in the place of the rows. I'm transposing my data if I want. Okay, David, that looks great, but we only work with these artificial small sets of data. How can I work with huge quantities of data? This admiration at the start means run this in the operating system. This is not Python code. This is Bash code. It runs on the operating system. And it's, let me show which files I have that are CSV. Tells me you have one file, Titanic dataset. How do you read a CSV file into a data frame of pandas? As easy as this. Read a CSV file that is called Titanic dataset, and let me show it. And here it is. You have read this file. It's in the repository, by the way. It should work in your computer. And as easy as that, you have all this information. Hey, I see that we have an index, and the index is numerical, but I have this passenger ID that seems like an index. I don't want both of these. Perfect. You can say the index column should be the passenger ID. Also, you can read not a local file in your computer. You can, sorry for that. You can get the data from the internet. So I have this URL, this gist in GitHub, which has this file. and read it directly from there. Instead of putting the file name, I put the URL. And now I have my data frame with all the data. And the index column is passenger ID, right? The big difference, instead of having this index column without meaning, I have the passenger ID as index column. And once I have it, I can see the shape. We have 891 rows, 11 columns. I can describe it, the numerical values. Age, we don't have all the ages, realize. We have 891 rows, but only 700 ages. We have the means, the standard deviation, the minimum values, everything. We can describe the non-numerical columns. Names, we have unique names for everyone. There are no people with the same name. Sex, we only have 2 sexes. And the sex with more values are male, 577 male passengers. And we have all this information, we can analyze it. Tickets, we have 681 unique tickets. Frequency 7 means there are 7 people with the same ticket. Cabins, we only have 147 cabins, distinct cabins, and there are 4 people in the same cabin. That's the biggest case. Embarked, we have this information. Okay, sounds great, David. We can read and read CSV files, but you promised me Excel. Okay, nice. We can write this data, which we have here, into an Excel file. And it's as easy as to say, this data frame, I want it to Excel, which with this name in a sheet that is going to be called data. Oh, and that's it. We have written the file. Let me show you. I have to hurry up because I'm running out of time. If I check the files in my project, now I have, it's not showing yet. Let me refresh. Here it is. Now we have a Titanic Excel file. I have already uploaded because I didn't want you to lose time. This is what I got. Nice, isn't it? All my data in the data frame, I can save it to Excel like this. Hey, but can I read an Excel file and put it into a data frame? Yes, you can. I have this file. It's in the repository too. It has a header. It has several columns, a lot of them, and it has a lot of data, right? And it has several sheets. Let me go down. For how can I read from Excel? As easy as this. Pandas read from Excel file. This is the name of the file, and this is the sheet I want to read, the diario sheet, right? Spanish. And show me the new data frame. That's it. You say, David, it looks horrible because it thought that the name of the columns would be the header, this diario header you had on the top. And the second line, the one that actually had the headers, got inserted into the first row, which should have made a mess of the data types because there are no numbers here. Everything is an object, everything is strings. because even the columns that has numbers has one row that has letters, that has a string, so it doesn't work fine, right? Because of this header in the spreadsheet. Okay, perfect. What we need to do is to say skip the first row. That diario in the top, skip it. I don't want that one. And that's it. As it skipped this diario, it took the columns the correct way, and it's showing me all the data in a data frame. As simple as that. And I can start to analyze all of this information. It's a data frame now. Let me show you. I can say backup, drive, backup, sorry. Here are the numeric values, right? And it tells me what do I have. Also, I can specify which line is the header. If the header of the data is the 10th line, I can say, okay, the header is in the 10th line. I don't want to skip anything. It works the same. And once we have this information in a data frame, we can do whatever we want. I want to select only 2 columns, hostname and size of application. I want to group it by hostname. I want the sum of the value. Why? Because it has, each hostname has several drives. I don't care about that. I only want to know I have 14 hosts in 203 disks, but only 14 hosts, and how much gigabytes I use in each one of them. I can do it more interesting. I want only hostname and size of application, or size of the disk, write it, group it by the host, get the sum, and I want to rename that column, size of application, only to size, right? Looks nice. No, forget about that. I want to plot it. I want to see it graphically. You only put plot, rotation 90 degrees, so the names are standing up, and I want bars, no lines. And here you have it. Here is the plot of each host name and the space each of them uses, like this. And this can be automated. You don't need to do this by hand. Okay. 20,000 gigabytes. Can we change these to terabytes? Yes, of course. I can say apply, which means for each value I want to run a function. It's a lambda function. I'm going to create the function right here. And the size you gave me, I want to divide it in 1 kilobyte, right? So I'm changing gigabytes to terabytes. And the renaming of the column, instead of size of application, gigabytes, I'm going to change it to size in terabytes. So I run this, and I have my graph. Now it's in terabytes. It says size in terabytes. The number is 20 here, and I see each of my host names and the values of each of them from an Excel file. That's what we can do with Pandas. Okay, thank you very much for being here. I hope you realize the potential of Pandas for helping us automate and get rid of Office, and the potential of Jupyter and Markdown to get rid of all these applications. No, you are not experts of this. You cannot do that in a couple of hours. We need more time, but I hope you get the idea of what we can accomplish. I put some next steps. Cheat sheets for Anaconda and Conda, a tutorial of Conda, a very good course. It's a very short course of Markdown, because Markdown is small. Markdown, as I told you, is not really complex, but this course is very good. Let's boss mastering Markdown. The tutorials for Pandas, and as you can spend a life learning about it, it has thousands of methods. It's very complex. Yesterday, no, Monday, I attended this session, the Idiomatic Panda session. It was great. I recommend you very much to go it. Look at like the next step. What I show you here is like the basics, the baby steps. This Idiomatic Panda session was great. It takes you to the next level of pandas. And we have this other library that we didn't cover today because we wouldn't have time. That's called OpenPyXL. This lets you take control of what you write in Excel. When you write a pandas data frame in Excel, it takes the data frame and writes it like that, right? It doesn't change format. It doesn't let you create a header, nothing like that. What can you do with OpenPyXL? The Excel file we load, the diario with all that information about the backups, it was created by Python using that OpenPyXL. I went for the information using AWS Boto3, a Python program that gets the data directly from AWS. And I use an OpenPyXL to create the report with that data in the specific format the client asked for it, because the client always asks things hard, right? Why to do it easy if we can do it hard? They ask for this title, these worksheets, this format, these columns. Okay, OpenPyXL lets me do that. Create the formatting, create the header, everything. It lets you get more control of what you use. So let me show you the file. This file, even the format, is what I created with OpenPyXL. And it lets you create several sheets, each one of them with different data, with the formatting, with the values, everything, right? It's more work. With Pandas, it's very fast, it's very easy, but if you need to, it works great. You can do great things with it. Summary. You cannot completely substitute Excel, and you cannot completely substitute Word. There are things you cannot do, even with these libraries. And let me tell you a secret. They do it like that on purpose, because they don't want you to stop paying their licenses. They always are going to invent something that you cannot automate in Python. Their business depends on it, right? We cannot get rid completely of them, but we can try. If you are willing to compromise, to say, okay, there are some stuff I cannot do, some formats I cannot copy, you can get rid of them. Stop paying them. Do it for free. Do it automatically. And if you compromise like that, you will save a lot of money and a lot of time. And let me tell you something, time is more valuable. Because money we can get more, but time we cannot get more. So I hope you liked it. It was a pleasure for me to give this talk. And we go back to Robert.
Thank you, David. This was great. I also use Pandas quite a bit, but although you say the tutorial is for the beginners, I learned a lot today. So I will definitely return to this video, review it, and learn a bit more.
Yes,
so also thank you.
There is an ocean in Pandas.
Yes, it is. It's amazing. Okay, perfect. Thank you.